Hi everyone. In the last video, we discussed what a linked list is, its applications, and how to traverse the list and display the data in the nodes. So, in this video, I am going to explain how to add or insert a new node into a linked list. So, there are three methods for insertion. So, first one is insertion a node at a beginning. Second one is insertion a node at a end. Third one is insertion a node at a specific position. Specific position. For creating the new nodes, I am taking this is N and B. New node at beginning, new node at end, new node at position. Okay, we will discuss one by one. So first one is insertion a node at beginning. New node at beginning. This is my new node. Okay. So for that, always the first node is head. Okay. Here remains. This is new node at beginning. Say N N B. So this name is N N B. And you have already an idea about this field is data and this field is next. That means address of the next node. Address of the next node or bracket link. Okay. So now I am going to create a new node at beginning. For that we have already how to create a node. There is one class is there, that is node class. Here to call this class, then we will create a node. So for that purpose, here I am going to write a statement here. NNB is equal to NNB is equal to node of say 5. NNB is equal to node of say 5. So here the data is 5. Automatically this is none. Okay. So what is the second step is, here we will create a link of this node in this next position. So for that NNB dot next is equal to NNB dot next. What is this address? What is this address? Suppose you have already some nodes here 10, 20, 30, 40. Earlier already we have created. Say this one is the address 1100, this one is 1200, this one is 1300, this one is 1400 addresses. You have already idea N1, this one, N2, N3, N4. Here what this 1200 you have to write here. So then the link is formed. If 1300 you will place here, then you will get a link to this node to this node. Here this 1400, this is your link. Similarly, you have to insert a new node at the beginning. What is the address of that corresponding node is 1100. So that here what we will do is we can remove this none write this 1100, then the link is formed. So that means nnb dot next. What is this 1100? This is nothing but head. So for that you will write self dot head, self dot head. So I already mentioned always the first node is head. Here the new node is beginning at the here the new node is inserted at the beginning. So this is the first node. This node is now first node, but head is pointed to the second node. So you have to move this head from this node to this node. For that, what we will do is here write one more instruction: self dot head is equal to nnb. So now this head is moved to here. This is head. Okay. In this way, you will insert a new node at the beginning. Okay. Now we will discuss at the end. Now we will discuss at the end. So that for that insertion, insertion at end, insertion at end. So to create new node, what is the new node? NNE is equal to new node at end is equal to, how to create node is node class, node, give the data, that is say 45. Now one node is created somewhere. Just for my convenience, I am writing here. So what is this field is 45 and this is none. Here already none is there. Last node. Always last node is none. Now, okay, and this field is data and this field is next or link, whatever it is. Next, what we will do is how to connect a link to this node to this node. How to connect a link to this node to this node. Say for this the address is 1500. How to connect this one? Here we have already know n4 dot next is equal to nne. But suppose user may create number of nodes, we don't know, 5, 6, 7, 100. So in that scenario, how to get that last node? So for that purpose, one temporary variable is used to traverse the all the nodes. So for that, I am going to create one temporary variable temp starting from first node. So temp is equal to starting node is self dot head. Temp is equal to self dot head. Now temp coming to here. This one is my temp. Here temp is equal to self dot head. Temp is equal to self dot head. Here this is self dot head. Temp is equal to self dot head. So now temp starting from the first node. Now every time we will go to the last node, up to that last node. What we will do is temp is equal to temp dot next. Temp is equal to temp dot next. So what happened here? Now here temp is there. So temp is equal to temp dot next. Temp dot next is, what is this value is 1100, for example. This value is 1100. Now 1100 is equal to temp. That means this is the 1100 address of the next node. Now temp move from this position to this position, that is temp. Okay. Next, again move to the next node. So again, now what is the temp dot next is 1200. Now here 1200. What is this 1200? It is the address of the corresponding the next node. So again temp is equal to 1200. Now this temp is moved from this to this position. Again temp is equal to temp dot next. Again temp is equal to temp dot next. What is the temp dot next is 1300. Now I am going to change this one 1300. What is 1300 is address of the corresponding next node. So that is temp. So that temp move from this position to this position. Again, what is the temp dot next? Next is 1400. So remove this 300. Okay, 1400. Now this 1400 is the address of the next node. So again this is temp. So move this temp from this position to this position. Up to the last node, the temp will move. So for that I am going to write a while statement. While temp dot next is not none, or simply you will write temp dot next. This is the for the understanding purpose I am writing extra lines is not none. You just simply write while temp dot next and colon. Okay, you need not to write is not none. Okay, so because while temp dot next is non-zero value means not null. Okay, so now remove this one. Now temp is up to here. Here observe temp dot next is now none, so it automatically exit from the loop. Immediately what we will do is, this node name is NNE. So this node name is NNE. So you can replace this temp dot next. This field is next. So that here you will write temp dot next is equal to, write this one is NNE. Now what happened? What is NNE is 1500 address. So this 1500 address is replace it with the none. So write here 1500, then automatically one link is formed. In this way we will insert the node at the end. Next one, node insertion at position. Insertion at position. Here position is nothing but here position is nothing but index. Index is always starting from 0. Okay, so now I am going to insert a node. Now I am going to insert a node here. Now I am going to insert a node here at position 3. So this is index 0, 1, 2, 3. Now I am going to insert a node here. So for that I am going to, okay. So for this one already you have an idea. This one is 10, 20, 30, 40. So addresses. This address is say 1100, 1200, 1300, 1400. So 1200 you can write here, 1300 you will write here, 1400 you will write here, then only the links will be formed. Okay, now my new node is this here, it is, this is 25, say address is 1250. But initially what happened here, if you create a new node, this field is none. If you create, say address is 1250. So now how to create new node at a position? You need to pass two parameters. One is position, another one is data. So for that, before going to that, so I am going to create at index 2. At index 2. Here I am going to create insert. Here I am going to insert node at position. So that is 25 at index of 2. At index of 2. So how to create node? So for that you will use NNP, node at new node at position is equal to node of data. Data is 25. I am passing 25. So again, always first node refers to head. Always first node refers to head. That is fundamental concept of the linked list. So now I am going to traverse this list up to this node, up to this node. So I am using the help of the temp. Here again I am going to use the variable temp. So for that, the next immediate step is temp is equal to first node self dot head. So temp is equal to self dot head. Automatically temp is pointing the first node. Now I am going to move the temp to the next node. So that for the temp is equal to temp dot next. But the temp is moved up to this before the insertion position. Before the insertion position, that is the index 1. So for that I am going to write a for loop for I in range of, for I in range of, position is 2, but we have to traverse up to 1. So for that position minus 1, position minus 1. So what is this range function? Range, now position is 2, 2 minus 1, that is range of 1 for loop. So for first initially I is equal to 0, I is equal to 0. So 0 in the range of 1, so means 0 less than 1 true, 0 less than 1 true. Now temp is equal to temp dot next. So what is the temp dot next is? Temp dot next is 1200. Temp dot next is 1200. So what is this 1200? Now 1200 points to the temp. So automatically what happened? This temp will move to here. Temp. If it is moved to next node, automatically you will change the position. But here next I is equal to 1. So 1 is less than 1, false. So automatically it is exit from this loop. So now the temp is remains at this index 1. Now what we will do is, here this is the temp, here this is the temp. This is your temp. Okay. Now what we will do is, this is your NNP node at a position. Now very simple, new node at position, this field is called, next. So here you will write NNP dot next is equal to 1300. So you are not supposed to write 1300 directly here, because you don't know what the address of the corresponding next node, but 1300 is here. What it is? It is simply the node is temp, this field is called next. So temp dot next is nothing but 1300. So now you will replace nnp dot next is equal to temp dot next. So automatically here one link is formed, that is like this. So what is this address is 1300. Next step. Now in temp dot next still it is 1300. So you will replace this 1300 with this 1250. So that means here you will write temp dot next is equal to, what is this 1250? You are not supposed to write 1250 directly. 1250 is the address of the NNP node. So you just write NNP. Now this 1300 is removed, 1250 is replaced here, then one more link is created. So in this way you will insert the node at a particular position. Now we will implement in Python. So this is our earlier code. Okay. Now I am going to create one more function, that is define insert underscore beginning. So self comma data insert. Just what steps I have written here: new node at beginning, nnb is equal to node of 5. So for that I am going to create a nnb is equal to node of data. Okay, nnb is equal to node of data. You simply write data. I will pass the data. NNB is equal to node of data. Here NNB dot next. See, NNB dot next is equal to self dot head. After that, self dot head is equal to NNB. Now that new node is head. Next one. Enter. Define insert underscore and self comma data. Inserted end. So for that again you will create a new node at end is equal to node of data. We will pass the data later. Enter. Temp is equal to, see, observe this code here. Temp is equal to self dot head. So while temp, you will write like this, while temp dot next, while temp dot next. So what we will do is temp is equal to temp dot next, temp is equal to temp dot next, and temp dot next, temp dot next is equal to NNE. This is insert at end. Now coming to that, define insert underscore position, insert at position, self comma, here two fields are required, one is position, another one is data. So for this function, similarly here NNP is equal to node of 25. So for that NNP is equal to node of data. Temp is equal to self dot head. Write for loop for I in range of position minus 1. Okay. In this, temp is equal to temp dot next, nnp dot next, nnp dot next is equal to temp dot next, temp dot next is equal to nnp. Now we will call the function one by one. So for that, first of all I am going to insert node at beginning. So insert node at beginning, copy this one, write SLL dot control V. Here pass the data. Here pass the data, that is 5. Say 5. Now run. See, observe. This is your, okay. Suppose now I am going to insert node at beginning 3. Control C. Enter. Control V. Place 3. Now run. So just I am going to use the comment. Yeah. Now I am going to run this one. Insert at end. For this again control C. Enter. SLL dot control V. Pass the node 45. Now run. 10, 20, 30, 40, 45. Again you will add at the end. Control C and control V. Here you will add 50. Run. 50. So again we will check the node at position. For that, copy this one. Here you will give two positions. Control C. SLL dot control V. Position is 2, comma, data is 25. Now run. Observe 10, 20, 25, 30, 40. So like that you will implement Python code, insert at the beginning, at the end and at the position. So in the next session we will discuss about the how to delete a node from the linked list. Okay, thank you.